Ash, I want to know, because of what I see with you occasionally,
Mm-hmm.
do you just look at that and just go x equals 4 on square root of y minus 2 without thinking?
Mm-hmm.
You have to think, what topic are we doing? No. What do you do next?
Well, actually, I don't even do that. I don't flip the signs yet. I'll flip them at the end.
Okay.
But
So there's either way.
yeah.
Over the years, I've been, do I do it this way, do it that way?
Yeah. So then I divide x by 4 to get rid of the 4 on top.
I really want to nag about one thing. This is a fraction,
Mm-hmm.
and that's a fraction.
Yep.
I can cross multiply,
Mm-hmm.
and the students go divide by 4. I'm going to do what you said.
Mm-hmm.
So you're going to go divide by 4. Tell me what to write.
X on 4 equals root 5 minus 2. Or root y minus 2, sorry. Oh, 1 on root y minus 2. There we
I'm
go.
waiting for it.
Yeah.
So I'm going to connect with your brain and see what your brain does before I criticise you.
Yeah, okay, so then you can just flip. So you didn't need to divide x by 4.
That's right.
So you just flip. So
Yeah. So now you'd have
root y minus 2 equals 4 on x.
Yep.
Yeah.
So you could have just gone swap places, and I want to nag about this swap places and when can you swap places.
Mm-hmm.
So if I had a plus 3 there, I can't.
Yeah.
Plus x, anything else, if it's just a fraction with just a fraction, 2 choices, I can go that by that, that by that. But the better one is swap places, which is what you did anyway. And what do we do next?
Squared right.
Now, do you write it in or just do it?
Just do it.
1 minus 2 equals?
16 on x squared.
Y equals?
16 on x squared plus 2.
Plus 2. Would you look at this graph or would you look at that graph? And what's the problem if we look at this graph instead of looking at that graph?
It doesn't give us the whole thing.
Oh, hallelujah. So the original will give away the domain arranged for that one. Whereas the domain arranged for that one, you've got to double check that all exists. How would you do that? How quick can you do that?
X can't equal 2 or less than 2.
That's right. So first thing I would go is, okay, that's, if it was 2.
Well, x can't equal 2 either.
That's right.
Yeah.
I can't equal 2 because of the square root, so
Mm-hmm.
Has to be bigger than 2.
it has to be bigger than 2. So we could instantly just say that the domain is, x is,
Greater than 2.
and can you imagine how often they probably say, I don't know, I haven't spoken to spec markers about it, greater than or equal to, be pretty common, I reckon. So what have we got? I'm going to put in, if I put in 2, therefore I've got asymptote there. What am I going to look for? I'm looking for nice numbers. How do I get nice numbers? 3 would be nice, because I'm going to have 4 in the square root of 1. Which is 4. So I know I'm going to have a 4. Is my graph going to be reasonable there? I think so. I've got enough room for it. What's the next nice one? I want that to say root 4, so I need that to be a 6. 6 take 2 is 4, root 4, 4 and 2 is 2. So by the time I get out to where, I have to move that. So what do we got? So I've got a 2, I've got a 2, I've got a 4. I should get a bit fussy and go a 4 and then go a 6. Go a bit more fussy and go an 8. So what did I say? I'm going to put in 6. So 4 over 2 is 2. Do we know enough now to do the graph?
Yeah.
Yeah. So I would say it's unmounted hyperbola. It's unmounted half of a hyperbola. So I don't need any more proof it's going to go up there. I don't need any more proof it's going to go down there. I could put in, say, 1,000. 1,000 minus 2 is, yeah, or better than 1,000, be 10,000. Why? Square root of 100 is nice. Square root of 1,000 is.
Wait, would it?
Give me a sec.
Yeah.
Square root of 10,000 is nice.
Mm-hmm.
So because you're halving the number of zeros, I don't know if you ever thought that through before. So I could go, well, that's about 4 and 100. So by the time I get to 1,000, I'm approaching 0. Go on, talk to me.
Would it be technically? Would it be? So I know it's not, but why is it not the hyperbola like that as well as underneath? Because it could be plus or minus. The y could be plus or minus.
Okay, when we write it in this form, It would be,
Mhm.
but when we write it in that form, it can't be.
But the square root,
There's no negative in front of it. If there's nothing in front of it, then it's a plus.
but the square root of, say, 4 is plus or minus 2.
No, it's not.
No.
Is it?
Square root by definition is only positive.
Okay.
Yeah, so when you say x squared equals say 9, x is plus or minus 3 because you can see it and you can put it in.
Yeah.
But when we say the square root of 9, it's not plus or minus 3.
It's only positive. Okay.
Square root of what is 3? Square root of 9. Square root of minus 9 is not 3, it's 3.
Mhm.
Important, mate, you've got to get me all those little things for you. So what do we say the range is? Y is,
Greater than 0.
and then you flip them around. So for the inverse, we now have the domain is,
X greater than 0.
yep,
Y greater than 2.
you're just swapping places. How would you draw the graph? Put a line through at 45 degrees. Rough graph though. Now you'd have to go, if I went different colours, I'd have to go a line across there at 2, and that's where it all gets very confusing and I've got lines everywhere. So you're better off to draw a separate graph, or are you? You can go things like this, 6-2 becomes, what does 6-2 become?
2, 6?
2 6. Yes mate, thank you. And here you're doubting yourself, but it becomes 2 6. And you fiddle around with it, so I don't know how much would I bother. I could, not here. What was that after? The inverse function, and its domain and range. So I didn't say draw the graph. Of course they could say draw the graph, but sometimes they don't. They just want the function and its domain and range.